This is the solution that I developed for the kaggle housing prices competition. So they provide us two CSV files. One is train.csv and the other one is the test.csv. And I actually used train.csv and to train the model, and the first um, the first 80% of the data I used for the training purposes, and the rest 20% 20% I used for the validation part. And at the end I used the test.csv and got the predicted results for the houses, and write those values to the submission.csv file. So first of all, I did the data pre-processing. So in the data pre-processing, so I considered about numerical data, categorical data, uh, as well as outliers. So um, so if you have like when I was analyzing the training set, so I noticed that it has some missing values. So in this example, like if it is a missing value, it might be something different from normal missing value, because like if let's say there is a house which doesn't have a garage, and so that house has to, the garage area column has to be empty for this particular house. So it's not actually a missing value, like it's not there just because it doesn't have that feature. So what I did was I didn't use mean or something. I just put zero values to those kind of to that kind of fields. And then categorical data. So when we are selecting features in order to build the uh, to build the model, so it is not easy if we have like categorical data in uh, so we have to transform them into numeric. So in here I have this um, lot shape, house style, overall condition. Those are categorical data. So at the beginning they had like string values, not numerical values. So now I'm here labeling them into numerical values. So I have done the same thing for both train and test set, and this part is for the removing the outliers. So basically we do not care about the outliers, because they do not help us to get the hypothesis, the line of best fit. So then I did the feature selection. For the feature selection, I divided it to parts, one for the categorical variables and the other for the numerical variables. So here I used scikit-learn library and its linear model. So um, these are the categorical variables that I considered when selecting the features, and I used sales price against them, and then I input these categorical variables into the this linear regression model. So I asked it to score each of these features and give them a ranking. So here I specific said that I want the best 5 features. So according to this model, it says like these features, the features that have the number 1 has the best impact. So the same thing with the numerical variables as well. So here also I got the best 5 features out of these numerical features, and then I trained the model. So I used decision tree regressor in scikit-learn library. So in the decision tree regressor, so first, when I was the first submission that I uploaded to the Kaggle, it um, it didn't have these hyperparameters in the hyperparameters. So because of that, I got uh, a, a less accuracy, which was around 84%, and then I redid the entire thing with these tuned hyperparameters, and then I got in actually this model, it it has accuracy somewhere around 87%, as I remember. So tuning hyperparameters is important. So I change these values to change these values several times. This is not like I'm putting the the first value and building the model. So if I increase this value, as an example, if I increase this value from 6 to 7 or 8, so that means I'm getting a lower accuracy than the present accuracy. So after that, I'm gonna fit this model with these selected features, and then I'm going to convert it to a numpy array. uh, so yeah, so this is the numpy array output, and this is the um, data. So these are the features that I'm going to be considered when I'm building the model. So these are the features, and these are the sale prices along with that. So then I have to split the model, split the data set that I have right now. So for that, I used this train test split method in scikit-learn library. So this is like slicing. So I'm slicing this array. This means like 0 to 10 means like including 0 but not including the 10th index. So up to 10th index, I'm gonna take all the columns up to 10th index and put them in this variable. So likewise that, then then I give xy here to split the data. So the test data set will have 30% from the original data set, and then they will be uh, put here. So this is just output. I just wanted to make sure that it worked, and here's the X train. So then after that, we are going to use we are going to fit the model with the training sets. Now it is X train and Y train. So the model is ready, and the prediction. So now we are going to predict what are the Y values, what are the sale prices for the test X values. So these are the prediction values. So here you can see my prediction values, and then I wanted to get an accuracy for this model. So first of all, so you can have this equation here. So it is mean absolute error. So what you have to do is you have to reduce this mean absolute error as possible, as much as you can. So this is the minimum value that I achieved. uh, so if you can lower this value more than this, yeah, that is good. And then this is how I got the accuracy. So yeah, this model has 87% accuracy. And then so when we are uploading this to the Kaggle, so they expect us to have a specific CSV file which which is required to have two columns. So if you have more than two columns, they're not gonna allow you to upload it to the site. So this is for the test data set. So I'm gonna predict the values for the test data set as well. So after that, that prediction value has to be written into a submission file and then upload it to the kaggle. So here the same thing happens. So I get the test data set and I slice it and then they predict those values. So now I'm writing those values to the so I'm creating a empty data frame here, pandas data frame here, and then adding id. So id has to be there. So one column is id and the other column has to be the sales price. So only two columns altogether. So this is the final prediction for the test data set, and then I'm writing it to the submission.csv. So this CSV file should be uploaded to the kaggle. So then as you can remember, I have considered this set of features when I'm building the model. So now here I am like visualizing those features against the sale prices. So I used matplotlib. um, so actually now since we are using this much of more than two features, we can't uh, plot them in the 2D uh, graph. Therefore we have to, if you're going to use it, we have to it's like n dimensional graph, so it's not possible here. So that's why I'm like taking these features individually and visualizing them one by one on 2D graphs. So here I got the lot shape and the lot shape against the sales price, and here the overall condition, the mass VNR type, the foundation, and all the so if you're looking at this, and you can notice that all the categorical variables, they have like uh, very linear type um, vertical shape graphs, because they have like set like fixed size. They don't have like point float values. They have like fixed round values. So that's why we can see a behavior like this. And then if we look at this grliv area, so that graph is like those points are scattered all over the graph. So you can see this is a good feature. And this total usable area. So total usable area is so when I was going through the training data set, so I realized that it had three columns. One is uh, the surface area of the first floor, and the surface area for the second floor, and the surface area for the basement. So what I did was I add those three columns together and then rename and create a new column called total usable area. So this is the graph for that one. Actually that one, when I was choosing the features, so that one was the model said it is a good a feature because of that, because of I used three columns to make that feature. So these are the other graphs. Okay, thank you.